But without further ado, we are here today to welcome Steve Gurysh and Dr. Benjamin Sikes for their artist talk. So they work with a material known as Mars Global Stimulant, which they will kind of talk about more in depth later on. And yeah, I don't want to spoil too much. I'm really excited about this. It'll be a very scientific artist talk. So without further ado, we have Steve.
Thank you very much. So yeah, my name is Steve Gurysh. I'm also an artist, but I'm also a professor teaching sculpture at the University of Kansas in Lawrence, where I also work with Dr. Sikes in biology. And we're going to have kind of a back-to-back talk where I'm going to talk about the development of my research and my work developing the show, and then about his research and how we intersect and are parallel in this sort of material that we both share as artists and scientists. But anyway, so the title of my talk is called Salvages. And this phrase is a phrase that I've come to describe this body of work that I've made for the show. When Kristen Taylor, the curator, came to sort of approached me sometime last year, at the beginning of last year, about the show and sort of introducing this theme and the questions that she was exploring in a group of artists. This work was very much in development, and I really appreciate working with someone who's willing to trust the process and sort of watch this work emerge in time for the show. But salvages is this term that refers to shipwrecks or cargo that is lost at sea or is recovered. It also refers to the salvage yard that you go to get a spare part for your vehicle. And there's also a really famous T.S. Eliot poem called Dry Salvages, which refers to this river and the sort of ongoing nature of its flow and all the things that pass through it. And this image we're looking at is an image of the surface of Mars, where for the past couple decades, NASA has been sending these rovers to explore the landscape and analyze it, figure out its geology. A lot of the missions are sort of bringing back all this data and trying to find examples of microbial life of some kinds or other sort of Earth-like processes on Mars. And the markings you see in the landscape are the sort of tire tracks of the rover. But flash forward to last June, I traveled to the Delaware Bay to experience this sort of biological ritual that has been transpiring for the past 250 million years. And so every full moon during the early summer months, these horseshoe crabs sort of emerge from the ocean and start breeding. And so when you sort of walk along the shore at night with this moonlight sort of hitting the water, you see this swarm of these crustacean-like prehistoric creatures. Horseshoe crabs are sort of referred to as a living fossil, and so they're an example of an organism that really hasn't changed much in its sort of physical biology for the past 250 million years. While all this is happening, there's also all of these sort of citizen scientists and volunteers that are walking along the shore, counting them, throwing these squares down and just sort of observing them. And this species is also endangered. So there's a lot of organizations in the Delaware Bay in particular that have been going out to count them and sort of understand how the species is sort of existing in relationship to this human impact. With species dwindling, you can imagine something that is that old, that ancient, and if it's being impacted, what that has to say about the planet. And so a lot of my work has to do with these sort of strange journeys that I end up taking, where road trips are involved and these great distances are sort of managed. And a really good example is this work I produced about 15 years ago called The Long Cloud. This took me to the South Island, New Zealand, and I went there with this sole purpose of collecting a sample of uranium ore in the environment. And it had to do with this sort of relationship between the country and its sort of this like mainstream anti-nuclear stance that it had taken since the 1980s, and also thinking about this relationship between photography and sculpture. You'll see how that sort of develops in my work as I talk about it. So this journey where I collected this uranium sample sort of resolved into this sculptural object where you'd find yourself walking into this room and you'd actually hear this sound, this sort of like clicking sound. And as you approach it, you discover that the sound is coming from this device, which is, does anybody know? There's this probe that sort of like went into this case, which is kind of strange. Why would an image be producing radiation? Well, this is actually a photographic technique called a uranotype that was developed in the mid 1800s, back when if you were a photographer, odds are you're probably also an amateur chemist because you're experimenting with all these different chemistries. And so a uranotype was one of these sort of resulting experiments where someone discovered that if you use uranium salts, you can produce this like very sort of reddish orangish tonal print that contains uranium as the sort of photoreactive element. So the image here is actually this image produced by this New Zealand photographer named Gil Hanley, and she documented the sort of period of anti-nuclear activism in the 1980s. And this particular image is of this ceremonial burial of a ship called the Rainbow Warrior. And if you were sort of up on your international news in the mid-1980s, you might have heard about this instance where the Rainbow Warrior was a ship owned by the Greenpeace organization that would actually go out into the Pacific Ocean to disrupt nuclear weapons tests, which sounds kind of insane, but they would do this, and it worked. And it worked so much that the French government, who was still at the time conducting nuclear weapons tests, didn't appreciate that activism. And so one day, there's an explosion on the ship as it was docked in Auckland Harbor. It sank the ship, and very sadly, one of the photographers, named Fernando Correa, died in the explosion. It was later discovered to be this actual active domestic terrorism and sabotage enacted by the French government, and became this huge galvanizing moment in New Zealand's culture to sort of like shift the conversation towards a kind of national anti-nuclear stance. And so this image kind of holds all of this kind of contested relationship between anti-nuclear activism and this like material that is so influential to that industry. And so thinking about the relationship between between photograph and sculpture, how a photograph could be an object. I've also been sort of expanding the idea, in my mind, of what an image is and what sort of technology we can use to create a kind of hybrid image object. And so I've been playing around with 3D scanning a lot. This is an example of something I've been exploring that's actually out in the gallery. That wooden carved piece called Blue Sky Thunder Days is the result of myself going out to the University of Kansas Field Station. There's this plot of maybe about 200 acres of land in Lawrence, Kansas, and within this sort of area, there's all of these different long-term ecological projects that various researchers are conducting. And one of these, which is sort of run its course, is this ash grove, where there's a planting of about 2,000 ash trees. They're all in this grid, and it's very like kind of creepy and mysterious when you walk into this forest. It's like a perfect grid. But what you'll notice is like 90% of all the trees are dead, and if not dying. And that's because of this emerald ash borer beetle, which is an invasive species. It's been sort of attacking these trees, not only in Lawrence, but all throughout North America, and it really threatens the American ash species as a whole. And so this is the resulting sculpture where I've been making this sort of like, a friend of mine actually mentioned this to me, he was like, are these like tree taxidermy? Like, because it's actual ash wood. So it's ash that I've sourced from Kansas City, where a lot of property owners are needing to cut down these trees because they're threatening to fall on their house, and so there's a huge influx of ash wood in the sort of like local wood industry in a lot of cities, and so you can kind of see there's like holes within the wood that are actual evidence of the ash borer, but there's also sort of digital evidence of it, of like a scan or carving it with a machine to create that same texture. And so, again, thinking about this idea of like the relationship between imaging technology and a sculpture, this latest piece, the other series of sculptures in the gallery, I wanted to talk about this artist, Robert Smithson, who made in the 1960s. You might have heard of Robert Smithson in relation to this land art piece called Spiral Jetty that is this like massive earthwork that's out in the Great Salt Lake. But he made these like really kind of quick and improvised images while he was writing an article for Artform magazine in the late 1960s called Yucatan Mirror Displacement. So he traveled down to Mexico and went to all these locations that were sort of around these Mayan ruins that were being, at the time, kind of uncovered for the first time by Western white archaeologists. And so what he did is he produced this series of photographs where he just went out into the landscape and placed all of these mirrors in the landscape. And so they're very sort of like confusing and oblique, but they also, cause us to have this sort of like forensic way of like looking at an image or looking at a landscape and not being sure what evidence we're supposed to pull from it. But there seems to be this sort of maybe relationship to technology with these mirrors. You see all these like footprints of like Robert kind of walking around to place them. But you also get a sense of like all these different ecosystems from one image to the next. It's like, red dirt to this like ocean scene to like deep in the jungle to this like river side. And there's been several essays and sort of like work research done about the sort of significance of this trip and this series of photographs. One of the connections people were making, and one of the things that Robert wrote about in his essay that appeared in this 1969 issue of Art Forum was that same year this other book was republished for the first time, this travelogue of this archaeologist, John L. Stevens, who traveled to the same region and produced all of these drawings and etchings of these ruins. And so Smithson's thinking about this idea of like ruin, leftover, and how do we like develop a perspective of the landscape that thinks about time and decay. But at the same time that his work is being made, the NASA astronauts are stepping onto the moon, and you can't help but notice a similarity between the images of the footprints of John Glenn and Neil Armstrong and the footprints of Robert Smithson in Yucatan. And so I've also been really fascinated with NASA photography and how this technology that was so fundamentally radical at the time is now a technology that we all have in our pockets. The idea of making a panoramic image was just like insane back then. Like they sent a robot that would take a video moving image of the landscape, and then there would be a human back on Earth that would physically print out different perspectives and then physically stitch them together. And so as a result, you get this really like tessellated image where there's a lot of distortion and a lot of like, you see the edge of each image. And so here's another one where you can actually see more clearly that like there's all these different prints being made and they're sort of being reassembled. And I just love looking at these images and seeing like the fractures and the gaps and how like the color temperature in one is like slightly different from another. And it really gives you the sense that like perception is not just this like live feed. It's the result of all these like multiple perspectives. And more recently, the past couple decades, we've been setting our focus on a different planetary body, which is Mars. And so these images are much more refined, and instead of analog, they're digital. And so a lot of their sort of combining is like a lot more seamless, but you can still see at the bottom of this image that evidence of like, okay, this is actually like stitched together, this sort of more aerial view. But preceding that, this is one of the first surveyor missions that NASA had conducted on Mars. But this is not Mars. This is actually Death Valley, California. And this is Carl Sagan, who's like kind of goofily standing with his like arm over his like robotic buddy. And I just find this image like so wholesome, but also like really hilarious, because it's like, NASA, we think of it as this like purely scientific mission, but Carl Sagan is like this person who really operates on this like kind of human level of like, how do we feel about space? And not just like, how do we think of it as this like abstract scientific concept? And so doing things like this where they're staging these photographs is also kind of comments on how we use Earth as this kind of analog for interplanetary experiences. Around the same time, they're shooting Star Wars and using Death Valley as a backdrop for another planet. This is C-3PO shaking hands with the National Park Ranger. Probably recently lost his job. Sorry. But this is an experiment I did a couple years ago where I suddenly found this website that had these open source LiDAR scans of places like Death Valley. So this is like an aerial satellite sort of 3D model of Death Valley where I use this machine to carve into these yoga blocks. And the yoga block component is kind of this like tongue-in-cheek way of thinking about like how these landscapes are not just places and geology, but they're like kind of these mental spaces for us. There are these places where we want to sort of project humanity into, think about as this kind of speculative place. And so, again, coming back to these Mars rovers, one thing that I've discovered over the past couple of years is not only have they been photographing the landscape, but they've been sampling the landscape. And what we've been doing back on planet Earth is taking this information and making simulated sort of versions of this geology. So this material that Ben's going to talk about in a lot more depth is this material called Mars Global Stimulant. And so all the sculptures in the show on the surface, they're sort of coated in this material. And it's a material that is supposedly like, you know, I don't know if it's 99% or 99.9999% sort of mineralogically accurate to a single point on Mars, but it's made up of all this different material that's sourced all over Earth. So it's made out of Earth. And it's this very heterogeneous material made up of all these different places to kind of simulate this other very far off place. And so the work in this show, I've been thinking a lot about this idea of distance. How do we bring really vast distances into kind of a single experience? And so this one piece that's out in the show is this diptych called River Where Footprints Can Be Seen. And so one thing is that the shape of these is they're car mats. And so this is a particular car mat from basically the first car I had as a teenager growing up, a 1993 Honda Accord. And car mats to me are this like really weird thing that they're not what you think about in terms of like high performance in a vehicle, but they sort of symbolize this like ground that, I mean, if you drive a car and you spend hours, maybe even years with your feet planted on this surface. And it's something that like collects material. And you know, Ben and I were talking about this the other day. It's like they're this like material that, like if you were to take a microscope to it, you might be able to say, oh, you know, I see this like sand from the Delaware Bay, or this mud from the dog park in Lawrence, and you might be able to piece together this like life of all these different places that you've been to. And so going back to this diptych, on the driver's side, the left-hand side, is a scan of a riverbed from the Allegheny River, which spans through Pennsylvania and New York State, which connects into the Ohio River, which connects into the Mississippi. And the image on the right is from the Kaw River, just in Lawrence. And both of these river systems for both of these rivers or these shores are actually connected in this like continentally expanding or expansive watershed. So like if I, put a drop of water in Lawrence, it could potentially connect to this river halfway across the country. And so I'm thinking about place as not this like sort of monolithic singular way, but place as this very distributed, connected, networked way. And of course, I'm also using 3D scanning as a way of kind of collaging these different materials. So there's like muddy footprints, there's rocks and sticks and other little bits of material, and a lot of these aren't just like one, or they're not even two. So I scanned a car mat, and then I scanned these locations, and some of these are actually like a combination of multiple scans, sort of collaged together. And when you like really zoom in on it, kind of like Smithson's photographs, it's like you're not really sure what you're looking at first. But what I really want to do with these pieces is sort of put you as a viewer into this sort of like mode of close looking and kind of looking as if you're like a forensic archaeologist. Like, what is that texture? What is that shoe print? Like, do I recognize that shoe? Is it from the 1990s, or is it from like, is it like a Croc, or is it a Merrill, or like a Nike shoe? What is it? And so all of these little like textures. If you were to imagine seeing this on another planet, like 1 million years from now, what would that person or consciousness think looking at this just really small detail of like a shoe print, or this like strange text that's maybe referring to a car company that existed in the 20th and 21st century. And so this is just a little insight into what I'm talking about when these are carved. And so all of these, and I can actually pass around some of these materials. So the pieces out there, they're not solid Mars Stimulant. There's actually just a small kind of layer of material on top of this high density foam material. And so this machine I'm using can like carve really crazy levels of detail. And I really like to think about this idea of touch in relation to this process, and remote touch. Like, what does it mean to make a sculpture where you don't actually touch it with your human hands, and you have a machine make it for you? But it also makes me think about this like rover that is on a different planet that's like touching soil, and somehow we have a connection to that now. And what I love about this machine is like I kind of imagine the tool that's cutting it is like this finger that's sort of like tracing along the surface of this texture, and how like intimate that is. And you can kind of imagine like looking at these surfaces, you like want to touch them, you want to engage with them in that way. And so yeah, here's me on the beach trying not to destroy this equipment that I borrowed from the University of Kansas, with the waves crashing and the sand everywhere. But to the right is like an example of one of these pieces in the process of being carved. And so again, this is me sort of documenting this this kind of magical biological event. And so the next day, the next morning, I came back and found all the horseshoe crabs that didn't make it back into the ocean, and they'd just been baking on the really hot sand, and most of them had expired and had been dead for several days. And you sort of walk around this sort of like mayhem of the shoreline, and so it was just a very strange experience, like witnessing this like profound sort of moment where these creatures come out of the water and mate and spawn and go back into the water, but then there's also this like death that's happening everywhere. That's really potent. But thinking about this creature in its sort of like 250 million year evolutionary timeline, it's actually really connected to our present moment, where horseshoe crabs over the past couple decades have been really instrumental in the pharmaceutical industry. And so the strange blue liquid being drained from them is actually their blood, and that's what it looks like. It has this crazy blue pigment to it, and it has to do with its sort of chemical makeup. Instead of having mostly iron in its blood, it has copper in its blood. And the way humans have utilized this is it's been a way to test vaccines and test for toxicity in vaccines. And so this species has become very useful to this industry, but also susceptible to kind of abuses within the industry and kind of over-harvesting. And so this is sort of like the current thing that's sort of impacting the species. But what's been interesting is now there's actually a synthetic version of this blood that's being produced, which now they're not having to like harvest these animals as much as they have in the past. But the sort of double-edged sword is there were like environmental protections placed on them when they were harvesting it, but now that they've made the synthetic version, these same environmental protections have been sort of released, which causes other issues for the organism. But I'll sort of leave it at that and pass it over to Benjamin, and we'll go from there. And after Ben talks, we'll have like a Q&A session with the work out there. So if you have any ideas percolating, hold on to them. We'll get to them. Yeah, thank you. First slide.
Yeah. Good. Goodish.
Cool.
Nice to meet you.
Yeah. I just want to make sure.
Yeah. In the back closes things.
Oh yeah, yeah. Do you want to do that right now?
Yeah, let's see. Okay, just make sure. Yeah, just look at this. Yeah, that's it. Plus it's like a little desk. Yeah, so Steve left it in a really cool place, and we've had some amazing discussions. The first time he emailed me and was like, "Hey, I heard you're working with like this Mars Global Stimulant. I'm doing that too, but I'm doing it in a quite different way. Do you want to get together maybe just to talk about what we're doing?" And we had a great conversation then, and honestly, I think the ideas were flying really fast. And at the same time, we were seeing like all these brilliant overlaps between his work that makes me think more carefully about how the work I do makes me feel, but also like how the structure of what we're doing scientifically is actually enmeshed in art and how we think about things. And so I'm going to try and provide a little bit about that. I'm a microbial ecologist. I'm also a scientist for the Kansas Biological Survey. And about 4 or 5 years ago, after I got tenure and decided that I could do more of what I wanted, I really love science fiction, and so I started working on things that were more science fiction. And part of that is thinking about how we might build ecosystems beyond Earth. So just to come back to what Steve was talking about first, we have to think a little bit about how dirt works on Earth. So if you don't think about dirt much, so soil has layers. If you ever go out and just take a shovelful, around here you might see a layering like this. So there are layers that change the physical and chemical and even biological components as one moves deeper in the soil. And in our region, especially, the upper layers are dominated by dead plants, basically, right? Like the remnants of plants. And in the middle picture, you can see on the left, basically, I just went and homogenized. So I mixed up this 20 centimeter deep soil core. I put some in this little tin. And the brown that you can see there is the organic matter, the leftover plant. And then we put it in about 1,000-degree Fahrenheit oven, and it burns off. So all the plant material burns away for about 4 hours. And what's left is just the clays and the minerals. And so we do some firing of our own, but in this case, what we're interested in is the difference between those two is all of the organic matter. So that's all the fertility in the soil. So we do it from a science perspective. But just like on Mars, the reason that it's red is because what's left behind is that the irons have oxidized, just like you find in ceramics, right? So a key question is like, where does all the fertility come from? We talk a lot around here about prairies and their deep roots. A lot of that comes from microbes. So on the right is just my fingers holding a little thimbleful of soil, and hopefully you can see like some small roots and hyphae. That picture at the top is a microscopic image that's showing the hyphae, and you can see all those bristles. A lot of that stuff are bacteria that just live on all of these things. So each thimbleful of soil is loaded with literally millions of these microbial organisms, thousands of different species. And yeah, most of them are unknown, most of them are unloved, most of them are unnamed. But it's these organisms that really break apart the dead plant material and work the energy of the body of the plants into the soil. So not only do the microbes inject plant nutrients into the soil, but actually the way in which a lot of them grows bind soil together. So if you were looking closely, I do because I like mushrooms, of course, but perhaps you noticed in some of Steve's pictures of the ash groves that there were mushrooms on the side of the tree and lichens on the side of the tree. And so all of those are doing the work of helping to recycle the nutrients from the plant. Yeah, I'm supposed to do this stuff. Yeah, so most of the time we tend to think of fungi like this, so big, charismatic things like that. This is actually like the apple on the apple tree. So this is the fruiting body of a fungus. This is a white rot, and so they eat a lot of bark and really tough material like lignin that's in the wood. But most of the body of the fungus, I'm not sure you guys will be able to see this. These are a few different cultures of different fungi. It won't make you sick, I've got them sealed. And we can't see because it's dark, but they can take on a lot of different colors, and those are like the threads that run through the different material. You can see some of them are puffy, and some of them sometimes are snotty. Those are the yeasts. There's all kinds of different ones. And so we culture them and play with them a lot. Not the classic kind of playing with them, but for example, our students sometimes will let them fight for March Madness. We have a March Madness. So those are the organisms that we think about that are living in the soil, not these guys. These is just the fruit of them. But one of the really cool things that they do is that fungi and cyanobacteria and other microbes really play a critical role in the physical structure of the soil. And you can see that in the bottom right. These are called biological soil crusts. And so they're really common in arid environments like deserts, mountains, even western Kansas. And just like the NASA photographer that Steve was talking about, these hyphae, as they work their way through the soil, are really binding together, the soil particles, the aggregates, and making it a single document, right? A single thing that is coming together. Steve pointed this out that our soils are really heterogeneous and complex. So across the earth, the geology, the parent material that's there, the climate, and the life there interacts to change dramatically. And so some of the soils that you can see here, similar to what Steve was talking about, all the weird places we go. This one's from the top of a mountain. This one's from like a pine forest. This is like a basin in the desert. And this is like an alluvial area, kind of what Steve has. That's actually in Lawrence. It's close to a prairie where there's a washout. And let's see. This might be a good time to do this. So we're not. Let's see. So this is just a couple of different ones when we went out and sampled. This is like a desert soil. So this is at the very bottom of the basin, and you can see how powdery it is. And this is up higher where there's kind of like some scrubby trees. So that's basin, and see if you can tell the difference. And then this is in the pine forest that's at the top of the Rockies. So we went up to the 14ers, over 14,000 feet. And this is like at the very top where there's just a bunch of rocks and not a lot of trees. And then this one is down where there's a lot of pine trees. And the key is all of these are 50 grams each, so the same weight, except this one, which is 25 grams. So the volume of soil changes dramatically as you start to get different organisms working it. Okay, that's the life that's making it so fluffy. Okay. Yeah, I think that's what I was saying. So Steve really talked about this, which I think is really important. The simulants that we try and use are trying to represent an entire planet or planetary body, which is kind of hilarious and ridiculous in the same. Like imagine that we had an Earth simulant, right, for all of Earth and all of the different kinds of soils that we saw before. So that's really a fraction of the complexity. This is a map actually from the U.S. Geological Survey, not of Earth's geology, but of Mars. This is like a Mars map of Martian geology. And hopefully you can see that there's just as much variation as there is on our planet. And we're trying to represent all of that with this Mars Global Stimulant, right? So it's really hard for us to do that. And the other part of it, which Steve and I have talked about, which I think is so cool, is we're taking a bunch of minerals from different places on Earth to try and make a simulant that represents an entire another planet. That's kind of like ridiculous, right? So it's really important to remember that heterogeneity exists and is really important. But at the same time, even though it might be disconnected from a single place on Earth, and it doesn't maybe represent a particular place on the Moon or on Mars, these simulants can be really important to help us, at least in my lab, in thinking about two elements. One is to really think about how we understand how we can incorporate the native materials there into building, into art, into the things that we do, into our ecosystems that we want to build there. And then the second is to start to think about how we can explore how Earth life might react to these foreign simulants and the stresses under it. So if you haven't seen The Martian, this is just Matt Damon portraying Mark Wahlberg and some cool things that you can do with that. So I'm just going to tell you 3 quick vignettes about work that we've done that I think are cool and represent these 2 facets. So the first one, we wanted to explore how we might combine lunar stimulant and waste streams as a foundation for growing things. So this work was led by Josh Williams, who's a student at Haskell Indian Nations University and was funded in my lab by the Bridge program, which is a National Institute of Health program. I like to say all of those words now so that we recognize that all of those things are happening. So Josh and I went out and bought some lunar stimulant, just like Steve's talking about. We went down to the Lawrence wastewater treatment plant, to obtain the biosolids. So these are a sterilized waste product from our sewage. They're already used on farms, and indeed they actually have some chemicals that we're kind of ambivalent or even negative about now, we think. But we wanted to understand whether or not we could mesh this simulant and the waste products, and whether or not A, life would grow on it, but 2, also can fungi integrate them better, right, in the way that might help us. And so this is Josh making his simulant. Let's see if it can work. So I just want you to listen. This one is Josh making some media with, let's do it one more time, with biosolids alone. Oh, thanks. Sorry. You want me to sleep there? And then this one, yeah, you have the other one as well. So this one is with the lunar stimulants. You hear the difference? Crazy, right? So we didn't know, we did know theoretically that the lunar stimulant is mostly made out of glass. It's kind of like that's a major component of it. We didn't know it until we started mixing them, and it started messing up all of our equipment, but also like that you could literally hear it as you were making the media, the difference when you had lunar stimulant in the mix or biosolids. And so Josh was able to make a bunch of these culture plates just like the ones I was showing you all. And this is a really common fungus in soil called Aspergillus niger that was able to grow just fine. We've also used it, it's really radiation tolerant. It grows just fine on biosolids and lunar stimulant. We had so Josh did this with several different fungi and found that almost all of them could grow on the 2 media. And in fact, what we found was about half of them grow better on biosolids and lunar stimulant than they do on biosolids alone or lunar stimulant. So these fungi actually like these different heterogeneity. They're salvaging what they want from different places, right? So we found that really, really cool. So the next steps, for example, might be to test it on other fungi, to try it with the Martian stimulant that we have. We might be able to use them there. And one of the reasons, So a second bit that we've been working with is to explore how the microbial communities we have here on Earth might be useful out there. So specifically we want to see if some of the really exotic microbial communities we have, like in Antarctica or in these deserts like Death Valley, could actually survive some of the stresses they might be exposed to out there. So I told you already about these biological soil crusts. They might cover up to like 70% of the landscape in areas like deserts, which can be dry deserts like Antarctica. They're dominated by fungi and cyanobacteria. They help us to control erosion and retain water. But really what we want to do was torture them. So we had 2 kind of key questions. The first is just whether or not these Earth communities can respond to radiation and temperature swings like they might experience on Mars. So Mars, right, it might be this kind of temperature during the day, but at night it might be minus 60 degrees or minus 80 degrees Celsius at the equator. And then the second question we asked is how that might differ if we had wet them before or not. So if they're wet, they kind of like are happy and growing, but most of their life they just spend like dormant in a hibernation state, like they're just in the fetal position for most of them. Okay, so we did that through these things that you can see on the right. I'll show you in a minute. The first thing that we did was go out and sample them. So we went to the Mojave Desert and sampled 12 sites, and we went to the Rocky Mountains and sampled 8 sites across the 3 mountains. And in each place we went to the highest point and then went down the mountain and sampled. And we shoved all of these microbes and soil crust back to Lawrence, put them in incubators that kind of represented where they were from. And then we either wet them or kept them dry, and then we tortured them. And so at night, some of them would go in a negative 80 Celsius freezer, so about 115 below. Some of them got exposed at KU Med facility to radiation, low or high radiation, that we tried to do like Mars. And then some of them got both, and some of them got neither. And then what we did is go out and sample the crusts over time after they had been tortured. Sorry, your picture. I think it's your pictures of the horseshoe crabs are making me think more about how torturous this was. So, hopefully this helps maybe with my guilt. So we've looked so far at 3 things I think that are taken up. So this is the highest dose radiation. We still have like seeds that were germinating from some of the plates, which was wild to me. So 3 takeaways. The communities after the treatments were really quite different based on where we got them originally. So if we got them from the top of the mountain versus further down, they still look like that, even after a lot of radiation and drying or wetting and nights that are like Mars. The second thing is that the individual stresses didn't seem to shift the communities very much, and that didn't matter if they were in their active state or their chronic state. So after a month, they really didn't seem to care that we had just tortured them. But we're analyzing the data now for 4 months because it could be one of these delayed things where now they all die, or there's some PTSD or something that they just are lost. So these crusts could be super important. So Steve was showing this as well. This is the InSight rover that we had on Mars that was driving around, and this is its solar panel. And actually it had to shut down in 2022. This is one of the ones that like have those nice messages at the end. It was like, I love you. Kind of things like that the NASA program intended. So the dust that's on Mars is really, really problematic. And crusts like this, at least in our habitats or around our habitats, could be really important, and especially if they can survive things like radiation. So this last little bit is really end up thinking how we use the biology of microbes to kind of help us support our own life and life that we might have out there. And so a really cool example of cool things like that on Earth are these salt-loving plants called halophytes. So this is a really good example called sea figs. If you are really terrible at growing things in your house, try sea figs. They're like pretty hard to kill. Cool thing that we've learned is that halophytes, like sea figs, one of the ways they deal with all the salt is because they have fungi and other microbes that live in their tissues. We call these endophytes, just inside the plant, right? And you can see some of them here. So these big rectangles are the plant cells, and on the outside you can see the fungal hyphae, threaded through there are the fungal hyphae. And then those can be really important. We can actually culture those out, like on these plates, and add them back to other organisms, here rice. And so the E+ on the left is with the endophyte, and the E- on the right is without the endophyte, and these both are salt-stressed rice. And so they can survive a lot of stress. We have that for heat and a bunch of other things. So this last bit that we're starting to do is looking at the salts that are on Mars. So Martian soils have very different salts than Earth. And one key example are the salts of this thing called perchlorate. So if you haven't ever heard of it, you don't really want to. It's pretty toxic to humans. It breaks down into some nasty things like chlorine gas, hydrochloric acid, other chlorines that are pretty nasty to us and all animals. So our lab is kind of trying to see if the endophytes that we could find out in salt-loving plants on Earth could be used to help plants grow on Mars, where they have to deal with some quite exotic salts like perchlorates. We're doing that through 3 little stages. The first one is just grow some lettuce and stress it out with different kinds of Martian salts, so like perchlorate. The second step, so the base soil there would be something like half potting soil and half sand, so it's like a half of soil. They like that kind of soil. So they just get stressed by the salt. And then the second step, we introduce the endophytes and ask, does that help them to survive those salts, those salt stresses? And then the third one, now we're bringing in the Mars Global Stimulant and asking not just are they stressed by the salt, but can they still help when they're in this physical environment that's like a Martian, right? And so these symbioses are really, really ancient, and I think hopefully this kind of bookends where Steve was talking about as well. The earliest fungal endophytes and plants were actually discovered at KU. They're over 400 million years old from the Rhynie chert. And these really proto-plants that were kind of coming out of water at the time, the earliest land plants, have a bunch of fungi that live in them as well. We don't know anything, of course, about what they were doing at the time, but of course a lot of people hypothesized that maybe they were helping them with the stress of learning to live outside of the aquatic environment. So I forgot to do this thing. I'm just gonna show you real quick because when we did, this is just a piece of bark that I got. Mike would be from an ash tree, no promises. But the landscape in the top of these lichens was really, really fascinating. So you can see like there's so many different species that are living here together, and they're different colors, and they have anthocyanins and all kinds of cool chemistry, melanin that give them different colors. But there's also pieces of them that over here. This is reproduction of the fungi. Those little volcanoes are all of their fruiting bodies. These are ascomycetes, and they make crystals and things like that out of them. But one of the coolest things is that we can go even closer, and it just shows you the heterogeneity of these landscapes. As you go down in, you can see all of them are intermingled with each other and growing over each other. And again, to me, it just makes me think forensically, like what you were talking about, Steve. But for me, I just look at these and think, oh, what are they doing? Are they fighting each other? Are they living in harmony? And they have the solution to all of our global problems. How are they making their lifestyles? And so it just makes me think as well. Kind of good pieces that you think that way. So that's all that.
Cool. And so I think we're gonna